In this video, the equations that we're going to solve have periods that are different from the normal 2 pi and pi that we're used to. So just for a quick review, remember that 2 pi is your period for sine, cosine, secant, and cosecant, and pi is your period for tan and cotan. Okay, so remember when you're looking at these problems, to figure out what the period is going to be, you're going to take the value that's in front of the x, let's say it's a 3 or a 5 or whatever, that's considered your b value. You're going to take that value in front of the x and you're going to do 2 pi divided by that to get your new period. For tangent and cotangent, you are going to take, let's say it's a 4, you're going to take pi and divide by whatever is in front of x. Okay, so it's either 2 pi divided by whatever's in front of x or theta, or it's pi divided by whatever's in front of x or theta. You're still going to start the problems the same way. You're going to start by isolating the trig part. So for this one, the first thing I would do would be to add 1. And then the next thing I would do would be divide by this 2 out here. So I would have cosine of 3x equals 1/2. Now, a lot of people want to go one step further and divide by 3. You cannot do that because that 3 is inside the angle that we're taking the cosine of. These things cannot be split up, okay? So what you're going to do now is you're going to figure out, okay, where in the unit circle is my cosine 1/2 at, just like we did with the previous examples. Where's the cosine 1/2? But this time, instead of saying x equals and then listing those angles, it's going to be 3x equals, and then we're going to list those angles. We take care of that 3 last. So in the unit circle, the cosine is 1/2 at pi thirds and at 5 pi thirds. That's quadrant 1 and quadrant 4. Now we take care of the 3. So we divide both of these by 3. And that basically takes our denominator and multiplies it by 3, so we get pi ninths, and we get 5 pi ninths. Okay, but we're not finished. Because our period is something different, we need to figure out what that is. Okay, so our b value is a 3, so our period is going to be 2 pi thirds. That's smaller than 2 pi, which means that this equation starts to cycle over after it reaches 2 pi thirds, so it starts repeating itself faster than a normal cosine cycle, which means there's going to be more answers before we reach 2 pi. Okay, so remember, when we find these answers, most of the time you're going to be told to find answers on the interval from 0 to 2 pi. So when your period is smaller than 2 pi, we've got more answers to find. So we've got our 2 initial answers. What we're going to do now is we're going to take this period and we're going to keep adding that period to our answers until we go over 2 pi. And once we've gone over 2 pi, we know that one doesn't count and we're going to stop there. Okay? Remember, periodic functions mean they start repeating themselves after they reach their period. So if we take pi ninths, which is really just 1/9, and we add 2/3 to it, change it to a fraction, we get 7/9. So 7 pi ninths is another answer. While that's in my calculator, I'm going to add another 2/3 to it. So notice I'm just going to keep on adding the period. That's 13 over 9. So 13 pi ninths is another answer. We're going to keep on going until our top number goes past 18. When we reach 18 over 9, we know we've reached 2 pi. Okay, so I'm going to add another 2/3. And obviously I've gone over 2 pi because my answer was bigger than 2 as a decimal. Okay, so that one I'm not going to count because we went over 2 pi with that one. Now I come over here to my other answer, 5 pi ninths. So I'm going to type in 5 ninths and I'm going to start adding 2/3 to this one. So add 2/3. Change it to a fraction, I get 11 ninths. So 11 pi ninths. Add 2/3 again. I get 17 pi ninths. And then if I add 2/3 again, I've gone past 2, so I'm past 2 pi. So these are my answers. So this problem has 6 answers. The smaller the period, the more answers you're going to have, because that means it cycles over more times and before it reaches 2 pi. All right, number 2. 3 times the tangent of x over 2 plus 3 equals 0. All right, so this is the part that I want to isolate. I'm going to go ahead and get rid of this plus 3 by subtracting it, which is negative 3. Okay, now I'm going to divide by this 3 out front. So I'm going to have the tangent of x over 2 equals negative 1. Okay, so now it's isolated. Remember, I can't get rid of that 2 until I've found my angles. So now I ask myself, where in the unit circle is my tangent a negative 1 at? Remember, tangent's negative in quadrants 2 and 4. And tangent's always 1 at your 45-degree angles where your sine and cosine are the same. So this occurs at 3 pi fourths and 7 pi fourths, quadrant 2 and quadrant 4. Okay, so I have x over 2 equals those two angles. Now to get rid of that divided by 2 right there, I'm going to have to multiply these two answers by 2, which makes my numerator up here a 6, and it makes this numerator a 14. And let's reduce those because we don't want answers that are not reduced. So this becomes 3 halves, and this becomes 7 halves reduced. Okay, so we don't want the unreduced answers. Now, if you'll notice, this answer right here is already bigger than 2 pi. 7 divided by 2 is 3.5. So that one's already over. So we can't even include that one. So right now, all we have to include is 3 pi halves. So let's look at what our period is. Remember, with tangents, your period is always pi divided by your b value. So pi divided by, my b value is 1/2. Remember, there's always an understood 1 in front of that x up there. So 1/2. Remember that dividing by 1/2 is the same as multiplying by 2. So my period is already 2 pi, which means the answers I found already cover up to 2 pi, since that's what my period is. So on this one, I do not have to go through and keep adding my period to my answers like I did up here, because my period's already 2 pi. Okay, so this one's a little different because my period's actually bigger than it normally is rather than smaller than it normally is. A larger period is going to give you less answers. A smaller period is going to give you more answers. So just 3 pi halves for this one. All right, let's look at number 3. 2 sine squared of 2x equals 1. Okay, so I want to isolate this by dividing both sides by 2. All right, so I'm going to have sine squared of 2x equals 1/2. And then I'm going to square root both sides. So now I have the sine of 2x equals plus or minus. Don't forget your plus minus. The square root of 1 is 1, and the square root of 2 is square root of 2. Okay, so if we rationalize that, remember we don't like to see square roots in the bottom. If we rationalize that, we get sine 2x equals plus minus square root 2 over 2. Okay, so we need all the places in the unit circle where our sine is square root 2 over 2, which those are our 45-degree angles, but we want the positives and the negatives, so we want all 4 quadrants. Okay, so we're going to have 4 answers initially. So we have 2x equals, in quadrant 1, pi fourths, in quadrant 2, 3 pi fourths, quadrant 3, 5 pi fourths, and quadrant 4, 7 pi fourths. Okay, so 4 answers. I'm still not done. Okay, I've got to divide by this 2. So I'm going to take each one of these and divide by 2, which basically makes this 4 in the denominators and 8. So we have pi eighths, 3 pi eighths, 5 pi eighths, and 7 pi eighths. So those are my 4 initial answers that are actually going to count, okay? Then we've got to figure out what our period was and go through and add our period till we go over 2 pi. In this problem, I do have something sitting in front of my x, so my period for sine is always 2 pi divided by whatever's in front of x, which is a 2. So the 2's are going to cancel. My period is pi. So I have to take each of these answers and add pi to them until they go over 2 pi. All right, now we can use a calculator for this. I hope that you would be able to add pi to each of these without using a calculator, because adding a pi is just like adding a 1, okay, but we'll use the calculator just in case. So I have a 1/8, and I'm going to add 1 to that, which is going to give me 9/8. I'm going to add another 1 to that, which gives me 17/8, and 17/8 is larger than 2. So that one has already taken me past 2 pi. When our denominator's an 8, we're looking for a 16 on top. When we pass the 16, we know we've passed 2. Okay, so I'm going to move on from that one. I'm going to go to 3 pi 8s. So 3/8 and add 1 and change it to a fraction, and we get 11/8. If I add another 1 to that, 19/8 is too big. So I'm going to skip on over to 5/8, and I'm going to add another 1. Ooh, wrong thing. And then I get 13/8. Add another 1 to that, and I'm at 21/8, which is way too large. So I'm going to go down here to 7/8 and add 1 to that and change it to a fraction. I get 15 pi 8ths. And if I add another 1 to that, I'm at 23/8, which is way over. So what I was saying about doing some of these fractions without the calculator, just remember that when you're adding fractions, all you have to have is a common denominator. So like if I was taking this 1/8, 1 pi 8th, and I was adding 1 pi to it, 1 pi is the same as 8 pi over 8, so that I have a common denominator. So 1 plus 8 is 9. So I should be able to do 9 pi 8ths easily without having to use a calculator all the time. But I know that sometimes we just worry that we're going to mess up, and so having the calculator is good as a security, but you should be able to do some of these on your own. All right, so those are our 8 answers for that problem. All right, and let's look at one that is a reciprocal function. So for number 4, we have 3 cosecant of 4x equals 6. All right, so we want to isolate the cosecant of 4x by dividing both sides by 3. So we have cosecant 4x equals 2. Just like in the previous problems, we don't like to deal with cosecant, so we're going to do its reciprocal instead. So the sine of 4x is 1/2. We can always change this to its reciprocal as long as we flip this. Okay, so what I want to know is where in the unit circle is the sign 1/2? Sine's positive in quadrants 1 and 2. So I want a quadrant 1 answer, which is pi 6, and a quadrant 2 answer, which is 5 pi 6. Okay, then we've got to divide by this 4. So that's going to give us pi over 24 and 5 pi over 24. All right, now we need to find our period and start adding it to our answers. Cosecant has the same period as sine, 2 pi. So we're just going to divide by that 4 right there like we normally would for a sine function. 2 pi divided by 4 reduces to pi halves. So pi halves is our period. So we're going to take each of these and we're going to add a half until we go over 2. Now keep in mind how we're going to know that we've reached 2. If our denominator is 24, our numerator has to be at least twice that. So our numerator is going to have to be 48 to know that we have reached 2. So it may take us a while. All right, so I'm going to start with 1/24, and I'm going to add 1/2 to that. Change it to a fraction. You get 13 pi over 24. I'm going to add another half to that. I get 25 pi over 24. I'm going to add another 1/2. I get 37 pi over 24. I'm going to keep going until I reach 48, remember. Add another 1/2. Okay, I see that I've passed 2 right here, so I know that I'm done. Okay, so I can stop there and come over here to the 5. So 5 over 24 and add 1/2 to that, which is 17 pi over 24. Add another 1/2, 29 pi over 24. Add another 1/2, 41 pi over 24. And add another 1/2, and that one should take me over. I'm past 2, so I know I'm over. And this one has 8 answers as well. So there's no set number of answers that you have to have. Remember, like I said, the smaller the period, the more answers you're going to have most of the time. So you could have 12, 16, 18 answers, or you could have just 1 or 2. So just always double check your period, make sure that you've added it until you've crossed 2 pi, and that should satisfy all your answers.